Hello there and welcome to my workshop and my channel. So as you are here watching this video, you must have some interest in CNC machines, of which this is a CNC milling machine for steel and hard materials. This is a small CNC milling machine that I have converted myself. So I made the kit myself, and the full conversion, including the electronic pack, all the details, plans, pricing, where I got my parts from, are available on my Patron pages. On this screen here, this is a program called Mark III. It's an American program, and I use this and other programs to run my CNC machines. So we're going to do a little bit of tuition then. I'll show you how to set a simple workpiece up, and we will machine it with this CNC milling machine. But first, I want to give you an idea of where you may start with CNC machines. Now, you've probably already looked on the internet, on eBay and wherever, to find out that CNC machines are not a cheap hobby. Well, that's not strictly true. Now, what I would advise a new person coming in on the CNC scene then, was interested in CNC machines in general, whether it's a CNC milling machine, router, or a laser. Now, this little CNC machine is bought off eBay and other places you can buy it. You can get into CNC machining for approximately $350. Now, I bought this machine, but I've done a lot of upgrade work with this. The standard little drive motor, okay, of which that's what this is, you can cut with it, and you can make a start with this, but it's a bit flimsy, and this is 100 watts. Now, this is the motor I bought again off eBay with its power supply. This is a 300 watt motor, and it's the largest one I would suggest anybody fitting on a 3018 or similar little router. The structure just won't take any bigger. And indeed, I machined this 3D carving with this. Now, I put an additional $150 to $180 into this to make it perform to machine a 3D carving or even cut something out. Because the standard machine, let's be honest, is a toy. This is a couple of steps up from a toy. Now, so I 3D printed, designed and 3D printed this new motor holder, and if I turn it around, on the back you will see there's a third rail. Okay, this is a linear rail with bearings and mounts, and I 3D printed these, and again all the necessary information and STL 3D files that you would require are on my Patron pages. So what I'm doing with you is I am establishing with you that for less than $500, much less than $500, you can get started with CNC. And I have a 5.5 watt laser for this as well, all in that price, in the original price. On my channel I've put in a playlist about 17 videos building this, how to operate it with free programs. In this case you use a program called Gerbil. I won't go into tremendous detail right now, but go and have a look at the playlist, and it will take you right from the very start of unpackaging to this and how to use it. Another very important thing I want to establish with you is you do not have to learn how to write G-code. If you've been looking on the internet at other people talking about CNC machines, they go into a lot of discussion about writing G-code. You don't have to. There are programs that take care of that for you. So I'm now going to go into a very simple program to use called Carveco. Now, Carveco comes in 3 different program levels. Now there is Carveco, which is the main industrial program. Then there's Carveco Plus, that incidentally is the one I should be using. That is the semi-professional or very highly skilled, shall we say, hobbyist. And then there's, for the starters, you, which is a program called Carveco Maker. So what I'm about to show you, any of the programs will do. So let's get started. So this is the opening screen of Carveco Maker Plus. To open a new job, you just go up here to this top corner where it's labelled New Model, press that, and then this little dialog box will come up. And this is practically the same in all types of programs like this. And this is the program where you do your artwork or your design work, and this program writes the G-code for the CNC machine. So we're going to say, well, it's actually set right for what we need. So it's I'm working in millimeters, so it's 55 by 55 millimeters. Actually, we could make it anything we wanted, really. But we will. We'll make it 100 by 100. And you can see that the diagram of our piece of work changes when you alter these figures. Now, resolution is, I always leave it on high. Now, this little red L, now that denotes the start of the program, alright? Or the start of your piece of work, where you want the G-code or the tool to start from. Now, that will come into play, and I'll be able to show you on the CNC machine what that is all about. Now, technically, it's called a work offset, alright? And in the G-code, if you're interested, it's called the G54. Okay? You don't have to worry about that. Okay? Now, you can start the job or start your G code from any corner that you wish, but we're going to be doing a circular job. Okay, we're cutting out a circle, which is where I would suggest anybody, if you're starting in CNC, don't go trying to make a 3D relief or carve a 3D relief or even lettering. Start off simple. We're going to do a simple circle. So we're going to start in the middle, which is what I would advise with a circular job. And we're going to press OK. So I know by the color of this that this is in the 3D viewing window. But we need to, a lot of people like or prefer to draw in the 2D. So we'll change it. Up here, these tags, 2D layer. And you can see I've got rulers here to help me draw whatever I want. So we're simply going to go over to this side, if I get my ear out the way, and pick a circular drawing tool by left clicking it. Little dialog box comes up here to assist you to get it perfect. So I'm going to come to the middle of the material, and you notice the cross, your cursor. When you approach the middle of the material, it'll change to a target. So Carveco has picked up, well, here's the center. Okay, this is called technically snapping. So it's snapped to the center. So what you do there is hold your left mouse key down, drag it out, and I've released it now. And I want the circle to be 55 millimeters. We're actually going to be making a medallion, okay, but there's a number of stages that we go through. So we're going to highlight that box up there, which gives you the diameter, working in diameter. I'm going to say 55.0, which is just a little bit over 2 inches. And we're going to say create. And there it is. So we've finished our drawing now, because we just want to cut that circle out. So now we have to do the tool paths. So to do that, we're going to now go to the 3D window. And so we go back up here. We finished our drawing now, and so now we're in the 3D window. You see how the picture changed? The ruler's now jumped to the actual material, and this changed to a gold or yellow picture or backdrop. So now we're going to cancel out of that, and we want a toolpath. Now you can go to get the toolpath dialog area in several different places. You can either go here over on the right hand side, or you can come up here, okay, and we need a simple 2D cutting strategy, okay? So I know things sound complicated, but they're easy really. So what we're just saying to Carveco is, well, it's a two-dimensional job. It's just a single cut, it's not 3D. So we want a nice simple tool path, alright, a way to cut it out. So it gives you a dialogue or a conversational. Another word for these types of things, these pop-up boxes, is a wizard. So we're going to open up a wizard now. So we're going to come here, it's a profile cut. We're going to cut the profile of that circle. Okay, so we're going to cut on the outside of it because we want to end up with a 55mm disc. So we're going to say profile. Now, to assist Carveco, so the program knows what you want it to do, right? If I come off the drawing onto the grey here and left click, you see this now has gone black. Okay, so that's indicating to me and Carveco that, well, nothing is selected. So to tell Carveco exactly what you want or what part you want it to cut, because there could be several different parts on here. Okay, so you just go to the circle, left click, and it goes purple, and it is highlighted. So that's telling you and Carveco it's selected. Okay, so this is a wizard. Now then, we want to first of all tell Carveco how or what part of that line you want to cut. So, well, we want to cut on the outside of it. Well, you have three options. So if I go up here, you can cut along the line, you can cut on the inside of the line or the outside of the line. We want the outside. So we've established that. The next thing is selected vector. It's selected. That's the one we want it to cut. For this simple job, these this top one here, don't worry about it. Not necessary. So we leave those alone. Okay. So we come down to here, cutting depth. Now I'm just going to get the cutter that we're going to use. Now this is a 6mm 3 flute, so it's got 3 cutting faces. Okay, slot drill or end mill, so it actually is made to cut sideways. You can actually drill a hole with it too, but it's actually made to cut sideways. That's a 3 flute. This is another one. This is normally used for aluminium, and that's a 2 flute. See the difference? 2 flute, 3 flute. Okay, so we're going to be cutting brass, and I can tell you from experience, a 3 flute is the way to go. This, by the way, is 1/4 inch, or thereabouts. So the start depth now. So what we want to do in this type of job is start off on the surface of the material. Okay, and I'll show you how to set all that up in a few minutes. So we want it to start at the 0 position. In other words, 0 position is the surface of the material. And we want it to go 3.6 millimeters. You just put 3.6. Okay. Tolerance, we're just simply cutting it out. We're not machining a really accurate part here. So we just want to cut this disc out. Now then, we're going to choose a tool. We're going to choose one of these. Now in Carveco, there's a large tooling list. So we're going to cut this as though it's very similar to cut to aluminium. Okay, now we're going to choose the tool and set up the speed and feeds. Now I get emails every day asking about speed and feeds. Well, this is where we're going to start you off. So it's an end mill, it's 6mm, choose that, and this is just for reference. Select it. So now we are going to set up this tool to our machine. And the type of material that it is, we can adjust this. So we can go into here, open this, we expand the wizard, step over. Well, we're just actually cutting a trench, so we're not worried about the step over. We can leave that, it won't step over. Step down. Now I can tell you now that that is a lot for that little tool. It's it would do it. It'd probably do it in one cut, but very slowly. Well, we want to make it easy for it to cut through. So we're going to tell Carveco now what we want it to, or the maximum depth that we want it to cut. All right, down. So we want to do it in layers to make it nice and easy. So we're going to say 1 millimeter, which is a 25th of an inch. If this was wood, it'd do 6 millimeters, no problem at all. But this is brass. Feed rate 20 millimeters per second. That's really fast. So we're going to reduce that a little, and we're going to say 10 millimeters a second. Plunge rate 6. Now, it probably would be okay, but I normally put the plunge rate, how fast it's going to go down in, at about 50% of the amount that it's going to travel along. So I'm going to put that one down as 5. Now then, RPM. Now, so you can see the difference here, 15,000 RPM. This is set for a router. Okay, so this little mill will do approximately 5,000 RPM maximum, and that's what we will be running it at with liquid coolant or flood coolant to keep the end of the tool clean. In other words, get rid of all the little tiny chips that's going to come off, and also keep it cool as the main thing. So we're going to say 5,000 RPM. And tool number 1, the tool number doesn't matter because this is a one tool shot thing. Alright. Now then, I practically always use Klein milling. It just gives a better finish. And we're not going to add lead-in moves. Lead-in moves is we're going to machine the outside of something, but we want to ramp in. In other words, we don't want the tool to go straight into the material. Okay, although it'd probably be all right, just going a millimeter, but it's not a very good practice to have. So what we're going to do is we're going to go down gently, but we're going to ramp down into our cut like this. It'll ramp in. So we're going to click ramping, and we're going to zigzag. I always use zigzag, which is this, and this is the degrees and length of zig and zag. Okay, this is okay, no need to change that. Zigzag height 1 millimeter off the top of the material. That's what that is saying. Well, that's fine. Safe zone, safe Z, in other words, the safe area for the tool over the material is 5 millimeters above it, and that's fine. So now we have to tell Carveco the dimensions of the material. What's more important is the thickness of the material, so it doesn't just keep on going down or anything like that. You're giving it a parameter of this material is just over 3 millimeter thick. So we're going to say it's actually 3.2 millimeters in thickness. So we're actually telling Carveco, well, we want you to cut all the way through plus a little bit more. That's what we're actually telling Carveco. Because if you remember, when we were setting up how deep we wanted the cut to go, we said 2.5 or 3.5, I think. So we're going to say OK. I'll have a look back up there now. 3.6. We told it 3.6. I already knew it was 3.2 millimeters, so we're telling Carveco, well, we want you to go further past the end of the material to have a nice cut all the way through. Cut it all the way out. That's what we're telling Carveco in numbers. So the next thing to do is to give it a name. Very simple. I abbreviate everything. As long as you know what it is, it's okay. So I'm going to say 35 millimeter by 6 millimeter. Now you're naming, what I was doing then is I am naming the tool path. Okay? The little program, the G-code program. And you say, calculate now. And there it is. It's done it. It's just written the G-code to cut that out. Now, we can come out of that, and we're going to simulate this now in the computer, in the program, and we will. Now what I'm going to do is I'm going to roll this over so you've got a better view of it. So what I'm doing is I've got my cursor over the material, I'm pressing the scroll wheel down, holding it down, and I'm moving it. And you can see the tool paths there, the rings. Okay, now we're going to cut it out. So we come here to simulate. Okay, standard simulation, simulate. Now there's the little diagram of the tool, and this is what's going to happen. If something doesn't look right here, it's not going to look right on the material when you've done it. Because what you get on here is what you get on the material. So let's do the simulation. This is exactly how it's going to do it. You see the ramp in move here? Ramp in, round, ramp in, around, and cut out. It's as simple as that. I didn't write any G-code, Carveco did. So now we're going to save that file onto a flash drive, and I'm going to transfer it into the computer, into Mark III, running the mill. So the way we save onto our thumb drive or flash drive, just go here to the symbol for a floppy disk actually, and click on that, which brings this dialog box up again. So we're going to choose, where is it? It's not in there yet. We don't want the C drive, so we're going to browse to find our thumb drive. There we go, and there it is there. Open that. So you see it's in the J drive of my computer. So it's 55 by 6. That's it, N mil. That's exactly what we want to save. And oh, here's an important thing. Now, in Carveco, there are many different what is known to be post processors. Now, certain machines have, shall we say, certain specific lines of G code written in them for them to operate perfectly. We've just got a standard Mark III. So we're going to write it in G code millimeter tap. That is the most basic G code. This is the only thing you need to know about G code. Okay? If you've got any type of CNC router or milling machine or anything like that, or even little 38 in, the language they all understand, every one of them, is either G-code millimeter tap or G-code inch tap. Depends on how you have your machine set up. Okay, so G-code millimeter tap. So we've established the type of G-code, and we just write it. It's done. There's probably, because it's a circle, it's probably a few hundred lines of code, because G-code is like, simply put, it's like coordinates on a map. You tell the tool to, well, you start here, then you move down here, then you move from there to there, from there to there, there to there, there to there, there to there, and so on and so forth till you go round one circle. And then in the G code it says, well, go down another millimeter at this point and then go round again. So that's what G code is. Very simply put. It's actually very complex. And to be quite honest, I only write a little bit of G code when I have to. I don't have to, because I've got this program, so I don't. Okay, so we cancel out of that, and we will now go to the milling machine and we'll load the G code up into Mark III.